Hello, everybody. Thank you very much for joining us today in this conversation about nanobubbles. I'm joined by Jan Erik Haagensen, who is the Senior Director of Moleaer in Norway, north of Oslo, close to the airport, as he just told me. Um, he will help us understand today the topic of nanobubbles. And over the next hour, we will cover the emergence of the technology, its general functionality, as well as its specific application to aquaculture. We are recording this conversation today, so feel free to share this at a later point if you think there's somebody in your network who might find it useful. If you look in the bottom bar, you'll find a Q&A function. You might have seen this before in other Zoom webinars. There you are able to post any type of question you like, and these will be visible for all. If you head to that Q&A bar, you'll see a little thumb. That means you can vote these up. And all the questions that get voted up at the end, we will try to ask. We are allocating about 20 minutes of time at the end for Q&A. So make sure you ask them in time and make sure you check what's in the question list to vote those up that interest you the most. All right, let's take this away. Jan Erik, thanks for being with us today. Would you like to say hello?
Thanks for having me. So yes, I'm very delighted to be here and shed some light on all things nanobubbles. Absolutely.
Very good. Let's get straight into it. All right. So Moleaer, the initial idea, and I know I'm pronouncing it wrong. I've practiced it. I'm just not getting there, but we might get there at the end of the day, and you can correct me now. How did it all come together? The initial idea.
Well, I mean, it all started back in 2016 with Bruce Schulten and Warren Russell. They are the founders of Moleaer, and it all started when they had a project in the Middle East, and it was a project where they had they had to develop a certain solution to oxygenate for an aerobic water treatment process, and that's when Bruce Schulten came across this method to introduce nanobubbles, and from there it took off. So it's been a fantastic journey since, and they started adding value within horticulture and agriculture, which is one of the biggest markets for Venturi injectors and adding oxygen in that space, and where they could see that nanobubbles had an effect on plant health and resilience, giving better yields and crop yields. And also within the wastewater treatment area, seabed remediation, and also surface water. So now, what I'm going to talk about within aquaculture, we'll get to focus on fish welfare and water treatment in that same space. So what we're doing here is reducing input factors to give a much more sustainable usage of oxygen, while reducing energy as well. So some of these details I'll get into.
Very good, very good. Thank you. Where did you come into the picture?
Well, I came into the picture. Well, my first introduction to the company was back in 2020. I was working for another company. So through my career, I've been dedicated to supply the aquaculture industry with products and technology to help them with the development curve and increase their efficiency, ensure fish welfare while lowering inputs in a sustainable way. It's been through fluid conveyance, and fluid conveyance is very related to this technology. So when I came across it, I worked 23 years in this industrial company, and when I saw the results and the bar being risen in so many ways, I was actually speechless. So, and I thought honestly that I would never change jobs after working 23 years in a company. But being a part of this oxygenation paradigm shift is the absolute best decision that I've made. So it's really fun being a part of this change in how to oxygenate and how to improve water.
Okay, exciting, very exciting. I love it when somebody is this
Yeah,
convinced and motivated
it's fun.
in his. Yeah, very good. Um, okay, so let's get a little bit into the technology background. I think this is also what the most people are here for. Generally, oxygenation methods in the market right now, not just in aquaculture, but generally, they are largely cones, diffusers, venturi systems, or sparges. They
Mhm.
are all fairly different in themselves, but then towards nanobubbles, how do they differ? Like, and also to the delivery method that Moleaer has.
Well, well, that would depend on what we're comparing to here. You mentioned a few, but typically we're talking about oxygen utilization versus energy usage. So you have, on one of the scale, on one end of that scale, you have diffuser technologies that introduce bulk gas into water, and with the buoyancy of those type of bubbles, way too much oxygen is wasted. So, and then you have on the other end, you have oxygen cones, though we're talking about gas transfer efficiency may be efficient if they are um, run and operated very evenly. Traditionally, they demand more energy and have a much larger footprint. But the real difference is the extraordinary properties of nanobubbles, and none of these traditional methods that you've mentioned have that. So that's where we really differ, is the water treatment properties of nanobubbles. And then there is one extra dimension to just the oxygenation, and that is the buffering effect of nanobubbles, keeping an oxygen level more stable.
Mhm.
Mm.
That water treatment property, that is very interesting because obviously you are addressing two different problems here with one technology that used to be not directly connected to this.
Mhm.
Um, what what are the properties of nanobubbles that basically lead to that water treatment effect?
Well, it's a few properties that go in symbiosis with each other. When you get down to the size of a nanobubble, you suddenly enter a realm of different physical laws. So when you get as a direct result of the size, they get a negative surface charge. And this negative surface charge is one of the most fascinating aspects of nanobubbles. Um, they because of the surface charge, firstly, and the size. Well, the surface charge itself makes them they're negatively charged, so they repel each other. They don't coalesce like bigger bubbles do. And also because of the size, the Brownian motion overwinds the buoyancy, so they do not break surface like a microbubble would. Um, the negative surface charge can perform chemistry. So, for example, in RAS systems, they work as a natural coagulant, helping skimmers and drum filters increase performance while lowering energy usage, for example, from blowers that are in such a system. So with that, you can reduce the energy usage, and this is then reducing the total suspended solids in a RAS system, for example. Also, when it comes to the biofilter performance, we see that we can improve the performance there because we see that nanobubbles have the effect to improve the nitrification kinetics. So higher nitrate production and a reduced nitrite accumulation. And that means a significant reduction in inhibitory conditions for nitrobacteria. So the reason for this is that the bubble size itself affects the microbial composition of the nitrifying bacteria, and then consequently determining the growth and thickness of biofilm to improve the efficiency of the ammonia removal. So, and that part is one of the most fascinating parts about nanobubbles.
Mhm.
And you need to have it in a circulatory system to utilize it in that sense. So it's a part of wastewater treatment in a sense, and it's very
Mhm.
exciting to bring that into aquaculture.
No, it's fascinating because there's an element of compounding value here over time with the bubbles, and also
Yeah.
like from the way I understand it, their small property basically changes the rules, the literal physical rules around them, and that changes the game for how oxygen acts and is dissolved in water. It's also a thing that probably most of us didn't immediately follow. So what we're going to do is we are going to drop a deck into the chat, a presentation where which everybody can view and download, and where all this information is contained and can be reviewed, including some case studies. Now, generally, is there a specific area of industry or of type of segment of process where it's most applicable, or maybe even areas where you still say, this is not where nanobubbles play, you're better served with the traditional oxygenation system?
Well, I mean, wherever water quality is critical, we play a role. Absolutely. Of course, I mean, each case is different. We're talking about design from a blank sheet of paper, or if we're talking about a retrofit. Of course, we have to approach each case according, because they're all different. But yeah.
So generally, that there's no areas you exclude. If it's oxygenation, we can work with nanobubbles.
Yeah, if it's oxygenation itself, we're talking about the fish's oxygen need. That's one thing. Then you're not necessarily in the realm of water treatment, unless it's in a RAS system. But if we're only thinking about that part of the equation, the extra properties that are brought is the effect that nanobubbles have when they're to be considered we can call it giving the dissolved oxygen a buffering effect. So you have a suspended reserve in the water. It's not that big, but it is there to stabilize a dissolved oxygen level that would be dissipating because of biological or chemical need in the water. So if you take if you compare that to, for example, cone oxygenated water, and from water that has nanobubbles in them, you will see that the water, the dissolved oxygen will be more stable because there's nanobubbles present. So
okay,
that's that part.
So approaching the main question for everybody who would be interested in a system like this: how does this impact my bottom line? Like, why does this help me?
Well, when it comes to oxygen utilization in itself, if we are talking about diffuser technology, poor technology, where it's coming out through a perforated hose or diffuser stone. This is technology where the bubbles at best will be micro bubbles, and they go to the surface. So there's a lot of oxygen that is wasted in that. So our customers see that the immediate oxygen transfer efficiency is so high that they're saving a lot on oxygen usage itself. If we're talking about, say, a cone, or even a Venturi injector, these are methods that need pumps, and in some cases many pumps, and at high pressure. And with our technology, you can take that pressure down, or even reduce the amount of pumps. So that's saying a little bit about the efficiency that nanobubbles have. So you are able to both lower oxygen usage, and if you're producing your own oxygen, you would then subsequently have let's say you're producing it with an oxygen generator that is powered by diesel, for example, diesel generators. That oxygen generator won't need to be running that much because you're utilizing that oxygen so efficiently. So you are saving money in that sense, energy usage. And in other cases, you can actually use less pumps, and then you're also using less energy. So
Okay, interesting.
those are areas within oxygenation in itself when it comes to the system. And then when you enter the realm of nanobubbles, water treatment properties, we're talking about increased efficiency of your water treatment process, and therefore less chemicals and less all the input factors in the water treatment process become different. You are able to save money here and there in the process, not only on the energy usage, but also when it comes to the input factors of keeping that water quality good.
Okay, that's fascinating. So we basically have two direct factors: a direct reduction of oxygen use, a direct reduction of electricity use because oxygen stays dissolved for longer. And then we have these interesting externalities around water treatment. And I think you have case studies around these water treatments that, generally, from my own experience, and rightly so, there's no more risk-averse person than somebody who is managing fish in these quantities, and they're rightly so. We're going to have to look at very good data to be convinced of these health properties of tiny oxygen. But it is a fascinating topic.
Absolutely.
So you talk about customers. There's been a lot of technology entering aquaculture in the last few years. I've been in this industry for 5-6 years, and which is very short. And when I started, it felt almost, compared to then, there's a lot more technology going on now than it was at the beginning. But you do differ in that way that you have systems actually deployed at large customers also in significant production, correct?
Yes, that's correct. So both when it comes to sea-based, when it comes to land-based, both in Norway, Europe, Chile, Canada. So we have systems deployed in most types of production. Absolutely.
Okay. I think this is fairly interesting, based around aquaculture is still a very fragmented business, in the sense of some farms are very, very big, some farms are very, very small, but they would all benefit of that level of technology. Do you have solutions for the biggest as well as for the smallest, or is it more like, okay, you got to be this many tons, that big a year, otherwise this isn't going to make sense?
That's a very good question. One of the things that make Moleaer a global leader within nanobubble technology is that we have a very scalable technology. So Bruce Schulten invented something that was scalable down from the smallest amount of water and up to huge volumes. So it's all about dimensioning this, and there are some operating parameters to work within. So when it comes to how the technology actually works. And we need specific physical operating parameters related to 3 factors. One is water flow, and then you have the water pressure itself, and then you have the gas pressure. So when we get the correct balance between these 3 factors, that's when our technology in that space works and will produce nanobubbles. So that's part of the you would call it the recipe of our technology working, and we can then utilize different flows, all from small to big, within that space. So
okay.
So yes, it's very scalable.
Fascinating. So basically, I could, let's say I've got 30 net pens across different sites, and I could say, okay, I will basically run an A/B test. I'll put one here, and I won't put one there, and then we'll have a good look at what it brings us in this one. But I could scale up just that net pen with more machines, or would I then have to swap out the machine itself?
Well, yeah, I mean, we would have to do a sizing correctly from the beginning, yes. But yeah, we can add nanobubble generators. I mean, we have to look at such a case like that from one, the biomass's need. That's number one. Number two, redundancy, and of course, being able to have that modular add-on if the conditions, the pre-existing conditions, change. over time.
Yeah, because all farmers have oxygenation systems in place.
Mm-hmm.
When I come to you and I say, okay, I'm happy to try this, do I need to make a compromise on existing systems?
I would say, well, when it comes to making a system from as a retrofit, like you're saying now, in the sea, no, there's no big issue around that. I mean, if you want to use a nanobubble generator in a land-based facility, some piping may have to be changed, and that may not be possible. So then a retrofit solution would have to kind of maybe be in separate pipes. But as long as there's a will, there's a way. We can utilize existing systems. We have to look at, case by case. Every retrofit that we've done has been different. We've looked at it from the need of the farmer, and what the objective is. And there's always been a different way of solving it at these different sites. So we're a water quality expert, being able to. It's not a blueprint solution. We're able to take our technology and put it in according to the customer's objective.
Mm-hmm. Very good. So far, deployed systems, let's take Norway as an example, since you are located there. What is the experience in the net pens so far?
Oh, and the net pens, they are absolutely delighted about the immediate efficiency of nanobubbles, oxygenation efficiency. They see that the oxygen levels rise extremely quickly compared to traditional methods. For example, delousing. You have delousing vessels in Norway where they use mechanical delousing operations, and they have to crowd the fish. And if the levels are below 80% in the sea, and that can definitely happen during the summer months, or even DO situations in September, October, very typical. They can't treat the fish. They can't crowd them because that's there could be mortality rates because of that. And with traditional methods, they've seen that it takes a long time to get the oxygen up to where they need it, and they're throwing away both oxygen to the seagulls because it's bubbling up, and too much energy usage producing that oxygen that's going to the seagulls. So when they used our technology and they were at all the way down to 60% DO saturation in the sea, they used our technology, and I have one of our customers came to us and said that they used 6 minutes from 60% and up to over 100% in the crowded space of fish, and they were crowding about around 200 tons biomass at a time. So that meant not only the obvious savings, but they were able to get things done right then and there, get going, treat the fish, and then move on and keep treating the fish for sea lice treatment. So that's something that we get a lot of feedback on, that they really enjoy the efficiency in itself.
Mm-hmm. That is an impressive time, especially considering the amount of water that is involved here. Do you have that case study in your case study file? Is that yeah? Okay. So everybody listening, you will be able to find that in the chat, and you can browse the case studies for yourself. I've seen another one which I found quite impressive, also around delicing, with I think we can name them because you named them in your files, which is Moeaer. And there has been an extension of the delicing time. They were able to delice the fish for 80 minutes longer.
Yes, that's a Chile case. Yes, absolutely.
Yeah. Could you talk about their setup?
The setup is that well, they what they do in Chile is they treat the fish with chemicals, right? So for the sea lice treatment process, and in that they have, so what we do is we add the chemical in through the nanobubble generator, so it becomes part of the oxygenation process in itself. And with this efficient oxygenation, we then, as you said, we're able to increase the treatment time by 80 minutes and achieving 85% removal of adult sea lice. And yeah, so this is helping the fish become calmer, not stressed, and therefore, because they have this enriched and oxygen environment, an efficient way of keeping that oxygen at an optimal level, we're able to then increase that treatment time. So yeah, that's basically the achievement, the result in that case.
Okay. Oh, thanks very much for getting into that. So we have quite a global audience in aquaculture. We spoke about Norway a little bit. Let's talk about some other systems. Let's say you take this to smaller systems in Africa, for instance, or you take it to the very ambitious shrimp RAS projects that are happening in the Middle East. What is your approach there? And can these people also talk to you? Are you also the man for them?
Yeah, of course. It's just reach out to me when it comes to all of these different cases. Our what our target is, I mean, where I'm based in Norway, and the target that I'm looking at is finfish production. But they can reach out to me via LinkedIn, via the website, or even directly to my email address. That I'm sure you'll make
Yeah.
it.
Yeah. We'll drop all of this information in the chat in a moment, and you'll be able to reach out to Jan Erik with any questions you might have. I see we already have 17 questions piling up in the Q&A. I haven't even opened this file. I'm opening it now. This will be interesting. And I think to allow for enough time, we're going to get into the Q&A straight away. Okay, most recent, most upvotes. For everybody who has not voted on a question yet, I'm going to give you 30 seconds to just jump into, I'm going to give you a minute because there are 17 questions, to just jump into the Q&A at the bottom in your toolbar, and make sure you upvote the questions you find most interesting. While we will do that, Jan Erik, you obviously have an American accent, but your background is Norwegian?
Yeah, I was born in Seattle. My family actually emigrated from Norway and had all their kids in the U.S. And when I was 4 or 5 years old, I moved back to Norway. So I have siblings and aunts and cousins that live in the U.S. So I've kept my accent.
All right.
But I've been living in Norway since starting school.
Okay. Very good. Okay, let's jump into these questions. For everybody who's raising a hand, thank you very much for partaking in this conversation. But due to the amount of people, we'll have to stick to the questions that are coming through the Q&A. So please, if you have a question, make sure it goes into the Q&A. And if it gets upvoted to the point where we have time, we'll get to it there. Now, Steve Pomelo, I'm going to butcher your names. I'm sorry. Steve. Okay, it just passed by Quintin Merlin, who asks, is fouling a concern with industrial scale nanobubble generators? If so, how is this managed? What is the ideal method for introducing the nanobubbles into the water? Those are two. So let's get to the fouling first, and then the ideal method for introducing the nanobubbles into the water.
When it comes to fouling of the equipment itself, I gather. So when it comes to our equipment, it obviously in water, for example, seawater, it would grow. There would be what do you say, organics, or it would need to be cleaned. And what that is, it's very simply done. We add a acidic cleaning agent in through the oxygen intake, and leave it for 5 to 20 minutes, and then it's just circulated out. So you have a CIP cleaning process, and it's very simple. It's our customers will attest to that. It's extremely easy to maintain, but to keep the efficiency up, it's natural that we would need to clean it, and the frequency of that is all dependent on the application itself. But it's always good to kind of set a routine. For example, once a month, once every other month, all depending on the application, of course. Yeah, preventive cleaning.
And the tag-on question to that was, what is the ideal method for introducing the nanobubbles into the water?
The ideal method, for introducing so the finished oxygenated water. That's all dependent on the application, of course. But as one can see in some of these pictures, I don't know if you've shown any, but we use different discharge orifices, and we can discharge it, fairly right below surface, and still not get any off gassing. This is all, of course, dependent on the natural laws within, Henry's law, temperature and salinity. Yeah, but yeah, it's
okay.
the ideal is to introduce it at a specific orifice size beneath water, of course.
Okay. And the pictures Jan-Erik mentioned there, you'll also find in the deck. So just review the chat, and there'll be a document and his contact details if you have any more questions around the introduction of the bubbles into the water. The next question from Steve Pomelot, who asks, can the dissolved oxygen supersaturation cause gas bubble disease in fry?
Not, we've done testing of that, and I mean, not that sorry, again, that disease.
Gas bubble disease.
Yes, exactly. No. We've done testing of that, and the nanobubbles are so small that they do not affect the fish in that sense. We've done testing up against injector technology over 1 month in one closed containment pen, and another with nanobubble. So both in tanks and in pen for post smolt, we've monitored fish health, both when it comes to gill health and when it comes to skin and mucus layers, and there's no detrimental effect to either.
Okay, very good. Thank you. I hope that answers your question, Steve. Now, the next one is Melissa Romans, who asks, can you expand on how nanobubbles affect the biofilm thickness, or suggest a reference with evidence?
That is a very good question. What we do see is when it comes to that's actually a question for our R&D team, where we're just getting back results from a RAS facility in Norway, actually, where we see the improved effects of the kinetics in the biofilter, and as I mentioned earlier, the what's it called again?
Brownian motion, the negative charge.
No, the what's it called? Standing still here. So back in January of last year, there was done a study and a review of bubble aeration in biofilter to reduce total ammonia nitrogen of a RAS system. And as a conclusion of that, as I mentioned, the bubble size itself affects the microbial composition of the nitrifying bacteria. And that's consequently determining the growth and thickness of biofilm to improve the efficiency of ammonia removal. So this is what we also saw in a study that we've done now in a Norwegian RAS facility, where we see how the ammonia conversion is more efficient once we added nanobubbles. To get more into the details of that, I'd like you to send me the questions, and I can get our R&D team to answer, because that's getting into the weeds of things.
Yeah, okay. Thanks, Jan Erik, for that openness to answer questions directly. You'll find his email address in the chat, Melissa, so feel free to send an email to Jan Erik. Very good. Moving on. You've got a lot of questions to answer. We're at 28 now, so I hope you got something to drink. Is dissolved? Nick Price asks us: is dissolved oxygen from nanobubbles available to fish in the same way?
The answer is no. Nanobubbles in itself are not. They're not. What's it called? You can't detect them with a sensor like you do with dissolved oxygen. So they're not available as oxygen in itself. But they are there to, as I mentioned earlier, to buffer that existing oxygen level that is being used by the fish, right? So it's creating a more stable oxygen environment.
Okay. The next one from Margus Rebane: can you use nanobubbles with ozone for outgoing water disinfection or treatment? What will be ozone dissolving efficiency, and how much can leak?
Well, when it comes to ozone, we can absolutely use our equipment to dissolve ozone or add that as nanobubbles. When it comes to that space, I mean, we have when it comes to ozone, it's a lot easier to dissolve than oxygen. So you will get a higher percentage in, and using nanobubble technology, you will get even more. It will be very, very efficient. And with nanobubbles, as I mentioned, this buffering effect is very much the same when it comes to ozone. And ozone has this decay period called half-life. And with nanobubbles, you're actually able to increase half-life, which is very, very interesting. Yeah, but this is an area. I mean, obviously, ozone is a little bit more dangerous to people, and in this type of environment. So we have a team that would then take care of making sure that such an application is correctly sized.
Perfect. Thank you. The next question is coming from Frank Schelling. This is, I think, an easy one for you, about efficiency. So how many % of O2 put into the water is transferred to the water, and how much is leaving to the atmosphere?
Well, our number when it comes to transfer efficiency is over 85%. That's and it can be more, it can be less. It's all depending on the application and the water quality and field conditions that we're talking about. Yeah.
Mm-hmm.
Of course, there is some relevant factors there that do play a role, but all in all, over 85% efficiency oxygen transfer rate.
Okay. And if I might add on myself, over time, like how long does that remain in the body of water at that whatever you oxygenized it to level?
again, that's depending on the field conditions, temperature, all it says. But if you're comparing to other methods, all of the properties that I've mentioned will, if you're comparing two traditional methods, you will experience that our oxygenation method will give you a more long-lasting oxygen level.
Okay, very good. Frank, there are also statistics and sources to that in the deck that we dropped in the chat. So have a good look there. You should find all the numbers you're looking for in the document. Moving on to Roland Weiser. Hello, Roland. Good to see you here. We did a webinar with Roland last year. As he was involved in a very exciting project with a large RAS farm in Germany, connected with sustainable agriculture. Hello, Roland, for waving. Does the negative charge of nanobubbles have an effect on pH value or hydrogen ions?
That is a good question. That yes, it does. But I cannot get into the details of that. I would have to ask you to please send me an email on that, and then we will get into the weeds of that question. Absolutely.
Excellent. Okay, Roland, feel free to send your email. Moving on. Next one, Marc Laberge. Last I was told, the smallest unit was around 40,000 Canadian dollars. I cannot convert that in my head to USD, but Google will do that for you. He is asking if there are any smaller units available so consultants could let clients try.
Yeah, absolutely.
There are smaller units available?
There are smaller units, yes, but I mean, we would want to get to know the application and everything. I mean, send us an email and we can find out what can be done.
Okay, very good. Yeah, Mark, make sure to put your country in that email so they know where to find you. Yeah, I hope that helps you. Very good. Moving on to Neil Stallard. Nanobubble generators usually produce micro and bigger bubbles as well during the production processes. Are there nanobubble generators that produce only nanobubbles?
That is a good question. When it comes to that, yes, our system also produces some microbubbles. As I said, we have an over 85% efficiency, and we're talking about the dissolved oxygen rate. Then you have some of that becomes microbubbles, and actually a very small percentage actually saturates the water that we convey through our equipment with nanobubbles. The thing is that yeah, once more the once more the question.
The nanobubble generators usually produce micro and bigger bubbles as well during the production process.
Right. Sorry. I lost my chain of thought. Another thing that you have to be aware of is that when you have very high saturated water, oxygen saturated water, we through our cortex, when the water is transported through our cortex, just a foot, not even just immediately after our cortex, the water will be super saturated, even up to levels over 400% of oxygen saturation. And when you discharge this underneath water through an orifice, it will become turbulent. And then when you do that, you can see oxygen going in and out of solution, right? So there's also that visual part of it that you have to be aware of, and what is happening in that discharge.
Okay, thanks very much. The next name is Finnish, so here we go. Fiskalier Haumakiri, I think. I'm going to try that. How much oxygen can you dissolve in water, oversaturate at low pressure, 0.2 bar?
Ooh, 0.2 bar is pretty low. We would like to try to keep it, at least 0.5, but comfortably around 1 bar when we use our technology. It can absolutely go higher, but in the around the value proposal of keeping energy consumption low, we'd like to keep it around that area. But yes, like I said earlier, we saturate. We have saturation up to somewhere between 450 and 500 %.
Okay. He's got some add-on questions here. Well done. You put 3 questions into one. Since the bubbles don't collect into bigger bubbles and they don't float up, is all oxygen not dissolved still in nanobubbles in the water?
Well, yeah, that's a good question. The nanobubbles themselves, they consist of a very small portion of the added oxygen. So it's over from the time that they are introduced into the water, and for a period of time, they're buffering that water, and then it becomes then the nanobubbles, when they're, if you can't really call it depleted, but when they still remain in the water and have all the other benefits that I've mentioned. Yeah. I hope that answers the.
Yeah, and then he's got a very good follow-on here. Will these remaining nanobubbles dissolve naturally in the water right away when dissolved oxygen gets lower in the fish tank, or will it be used up in other chemical reactions, right? The biofilm.
Both.
These things.
It's both. It's both. I mean, it's in the driving force of when the dissolved oxygen lowers. That's when the buffering happens. But also, if the water has contaminants in it, because of the surface charge, they're attracted to other hydrophobic surfaces. And if we're talking about this pathogenic material or something that they can react to, they will react and collapse, and they will generate an immediate hydroxy radical as a mild disinfectant. So in best case, they can inactivate a smaller, weaker type of pathogen, if you will, or weaken it, right? So they get used up in that sense as well. You can utilize nanobubbles strategically in a system if you want to enhance your AOP, your advanced oxidation process. If it's ozone, UV, that could give a small extra boost to that system. For example, if it's underdimensioned, adding nanobubbles so that they become part of that oxidation process is a way to add value or enhance such a system. Yeah.
Okay, thank you very much. Moving on to the next question from Dries Rondeles. Again, I apologize. How do nanobubbles affect the growth of the fish, especially in freshwater systems?
Well, I mean, we're talking about oxygenation in itself, and it's there's a lot of literature around keeping the optimal oxygen levels, and with nanobubble technology that enables you to do so, keep it stable at a level that you want. So that's one part of it, in order to give them the conditions for growth and welfare. And then you have the indirect way, and that is that the nanobubbles are actually treating that water, reducing total suspended solids, and all of the benefits of the nanobubbles in for example a RAS system will then you will then create a better water quality for the fish. So that's indirectly creating better conditions for the fish in that sense.
Okay, Very good. Matthew Else asks, are nanobubbles appropriate for flow-through aquaculture systems?
Yes, absolutely. We have that in several flow-through systems today. It's I don't have any other answer to that. I mean, it's you will increase oxygen efficiency. You will be able, because of the there are other properties. The hard shelled surface of a nanobubble gives a mechanical property of scouring. So you have when you transport nanobubble enriched water at higher velocities through pipes, they will then penetrate the biofilm if there's biofilm present on the pipe walls, ripping it loose to surface and keeping those pipes clean. And since the nanobubbles have a negative surface charge, they will coat the piping, preventing biofilm from easily reforming on those surfaces. So that's
okay.
another area where you can add that, and also in a flow-through system.
Excellent. I've just been told by my assistant that the files haven't reached everyone yet in the chat. We'll fix that in a minute, so just stick around and we'll make sure all the contacts and the documents get to you. Sarah Richard asks us, there are publications showing that nanobubbles decrease the amount of certain heterotrophic pathogenic bacteria. On one hand, this is very interesting, but on the other hand, the question arises if nanobubbles would negatively affect symbiotic aquaculture systems, for instance, biofloc. Can you comment?
That is a question that I would have to take care of by email. Absolutely. Mm-hmm. But I can't comment on that here now.
Okay. Yeah, absolutely. Sarah, feel free to send Jan an email. I am dropping everything in the chat as we speak. Just give me a second here. It does let me. It lets me. So please have a look at the chat. There is Jan Erik's LinkedIn profile, his email, and the case studies in the link below. So that should be everything. Moving on to Frank Scherling, who has a very practically oriented questions. We like those. Is the transfer efficiency dependent on the tank depth, and what is the optimum depth?
Well, I mean, as you the efficiency itself isn't in that sense, but what I want to direct your attention to is the fact that nanobubbles do not have buoyancy. And if you have a flow direction in that tank, you want to try to get it into the direction of that flow where it's starting, so that it can follow the flow process in that tank. So adding it in the direction of the water flow would be beneficial.
Mm-hmm. Okay, yeah. Frank, I hope that answers your question or that helps you. And we are moving on to Mark McClue. In layman's terms, can you please clarify the correct quantity of nanobubbles to state approximately in 1 milliliter to express the difference between alternative aeration methods? Thank you. Diana, let me know if you understood that. I had my troubles.
Yeah, well, it's about how many nanobubbles per milliliter of water we're able to add
compared to alternative aeration.
Well, I mean, there are no nanobubbles in that sense. I mean, yeah. Alternative aeration would have larger bubbles, but we're able to add, depending on the water quality itself, we're able to add up to 1 billion nanobubbles per milliliter of water, and that's essentially less than a teaspoon of water that we can add that amount of nanobubbles to. Yeah. And again, that's dependent on the water quality.
Okay, very good. We hope that answers your question, Mark. Moving on to Halianto. In oxygenation, are we using pure oxygen or just air?
Both. I mean, well, I mean, the thing is that that's a good question. The thing is that pure oxygen, it all depends on the objective. So pure oxygen would be beneficial in a situation where you are trying to meet the oxygen demand of the fish, obviously. If you're using an oxygen generator, that oxygen level would be a little bit less. We're talking 93 or 95%. But if you're going to be using air, I mean, in some aquatic systems, that's enough. But for the aquaculture industry, we're talking salmon, trout farming, as such, we would want to focus on oxygen in itself. If you are in a RAS system, it could be better to use air at a specific point in the process. Say, for example, around your drum filters, right? You would add nanobubbles just using air, right? Because the objective is to improve the total solid, the suspended solids removal. Another area would be for your heat exchangers. You could actually add nanobubbles before going into the heat exchangers by using air, and that's related to the property that I mentioned earlier about the scouring effect. So when you do that, you add it in through to keep those heat exchangers cleaned. And anyone that's been working in a facility where you have heat exchangers, there have been a few swear words when it comes to dismantling that to keep it clean. So, and that's another area where we can add a little bit of value. Yeah.
Okay, very good. We have 2 minutes left. At least one question, maybe two. Torsten Wammen asks, what is the power consumption per kilogram of dissolved oxygen?
Well, when it comes to I would say that I don't have that number, but I would say I could tell you that our SAE on that is around 11 kilos per hour. So that would tell you a little bit about if you know about the SAE of transfer. Yeah.
Okay. Torsten, I hope that answers your question. You should be able to find more information also on the deck we put in the chat.
As well.
The last question from Gustavo Salazar, and then we sadly have to wrap up. There's still a lot more. Thank you all for the questions. Gustavo is asking us, is there any research about which size and or concentration of nanobubbles is better for the different aquaculture applications?
Well, I mean, we have a huge library of scientific publications. I can, if you send me that question, I can be sure to find whatever relevant information we have on it and send that to you.
Perfect. Thank you very much for asking, Gustavo. Jan-Erik will answer your questions directly. Please all refer to the information provided in the chat to reach Jan-Erik. He is janerik@moleaer.com. Also on the website, you'll find more information around the case studies. The day-rate case studies are also in the chat. So please reach out. Thank you very much for attending. Jan-Erik, thank you for taking the time and the breath to answer all these questions. I thought it was tremendously interesting to learn about this very, very interesting new method to oxygenate water. And yeah, I'm looking forward to see where Moleaer is going and if nanobubbles become the new standard.
Absolutely. Thank you very much, Moritz.
Yeah. Have a great day. Bye-bye, everybody. See you on the next webinar on the fish side.
Goodbye.